If you have the habit of reading, you have access, like you have the key to the entire knowledge that is available in the world. Entire knowledge in this world is available out there for free. Only thing is, do you have the key or skills to exploit them? Like there is everywhere, basically, let's say we can consider there are treasure boxes available all out there. Basically what you have to do is you should know how to open those treasure boxes. And if you know how to open that box, there is no barrier. And that learning is a continuous process. The day you say, I have learned everything, that means you are dead or you have become God.
Thank you for joining the Transform Impossible, which is India's first future tech podcast. And today I'm really happy to have with me a 20-year-old AI researcher, Gagandeep Reehal. He is also an author, a technology entrepreneur, and currently building a startup, -0, which is working on self-driving cars in India. So Gagandeep, it's a pleasure to converse with you because there's not many 20-year-old who I have come across who has really pushed the understandings or the capabilities of what can be done. That I think the future of mobility is going to be very exciting because presently we are so caught up with the IC vehicles and it's caused so much harm to the environment. There's some 8 million premature deaths in the world in 2018 due to fossil fuel, and this is largely because of IC vehicles. And that study also suggests that 1 in every 5 person dying globally is due to fossil fuel pollution. So I personally am really excited for the future of mobility, be it your electric vehicles, solar vehicles, autonomous vehicles, Hyperloop or eVTOLs. So I'm really excited for the space. So let's start by Advanced Driver Assistance System, ADAS, what we call it. What is it and how is it adding value right now?
So ADS is basically what you call, there is someone to assist you while driving. Break it down simple, let's say there is someone that is simultaneously sitting alongside you while you're driving, and in case, let's say you suddenly for a moment you look to other side, or let's say maybe you get sleepy, for that very particular, let's say, instance, for like emergency situation, that vehicle will not yet, basically system will not yet let your vehicle go astray. And let's say if you are changing lane and suddenly someone, like another car from behind, suddenly tries to cross you over, so that even in the places where your reflex action might not be that good, at those places the system can either alert you, let's say just slow down the vehicle, overtaking the decision of the passenger. So basically it's like someone else is always simultaneously keeping an eye on you, but that thing is, system can only keep an eye, it cannot drive your vehicle. It can help you in case you might commit error somewhere.
So you're saying that these systems are just driver monitoring systems. So could you kind of like give some examples, because there are some companies who are, who have these dash camera solutions with artificial intelligence or AI on there and stuff like that. So could you kind of like give some examples of which are the companies who are in this space, and which are there some fleet management companies or things which are using this solution?
So you want it, call it basically driver monitoring system. They're road monitoring system. They monitor the road. Driver monitoring can be like if the person gets a little bit sleepy, that is just something different. So they can like their road monitoring system. That is the first thing. Now in ADS system, there are two. One thing, almost all automotive companies are working on this. You take it from Mercedes, Volvo, and everyone is putting ADS system in their high-end cars. And almost every vehicle that costs above, let's say, 20 lakhs in Indian rupees has some or other kind of ADS system inbuilt in it. And even Indian automotive players, Tata and all, they are trying to put it out into there. And Tesla, the major global brand, that already has very advanced ADS system, I would say, incorporated in that. And then there are certain companies, particularly comma.ai, which I guess they develop dashboard cameras which can be installed in particular, let's say 5 or 6 vehicles which have CAN buses basically installed in it, which have, I would say, electronic power steering. So they have those kind of dashboard cameras So that is also one business model that is working. So I think these are major automotive players plus couple of startups who are working on ADS systems. In India, there is a company Flux Auto.
Right.
They are basically developing level 3 autonomy for trucks and other logistic vehicles, basically, let's say buses and all.
So these driving monitoring systems, they have external facing cameras, which does the road monitoring. Plus, there is internal facing cameras, so that if the driver is sleeping or he's distracted, and those can be notified to the fleet management. Now, let's break down the autonomous vehicles. The SAE classification says that there's 5 levels of autonomous. So can you break it down to my audience? From the level 1 to level 5, what are the levels of autonomous vehicles?
So there is basically not 5 but 6 level of autonomy.
Right.
One is level 0. That is the way we humans are driving. Everything is done by human. Then level 1, 2, and 3, they are basically some or other kind of ADS system. The advanced one, basically, level 3 is very advanced ADS system. Level 1 is little bit. So what they can maximum do in those 3 levels, let's say it can keep your vehicle on the straight road, or let's say if you're changing lanes, it can automatically give indicators, or it can even control your vehicle a little bit. Driver monitoring system, road monitoring system, all these come basically in level 3. The vehicle can basically drive itself for longer period of time on itself. Let's say in autonomous vehicle, we measure it by disengagement rate. So what is the minimum average, what you call rate at which the driver has to take over? And then comes level 4 autonomy, in which let's say computer can drive itself for, let's say, maybe an hour, provided it's a geofenced area. What do you mean by geofenced? Let's say, okay, in urban cities or metro cities, the computer can continuously drive for 1 hour or even more, but it might not be able to drive in village or maybe in hilly areas in India. So, and level 5 is what we call the ultimate master thing. That can, whether you are on desert, there are no roads, you are in a desert, you are in a hilly area, or even if you are, let's say, you are anywhere in the world, you can drive it.
What caught my attention, that at the age of 16, you started writing books, already authored 3 books. Who is Gagandeep Reehal? What excites you, and how did you manage to motivate yourself into pushing or going after a very, very bold and audacious vision? What is it that drove you to try and go for the impossible? Maybe you can also talk about your books and your journey.
I really owe it to upbringing to my mother. On each birthday, on each achievement, let's say I got good marks, something, I used to never ask for, let's say, video. I never played a video game in my entire life. Instead, right from kindergarten, my mother used to bring they were comic books and story books like Tinkle, Magic Pot, all these. So that inculcated the habit of reading in me. And I think this is the most vital, because if you have the habit of reading, you have access, like you have the key to the entire knowledge that is available in the world, whether it's on internet, whether it's on, let's say, in books, whether it's in media, anywhere. Building that kinds of habits from the very kindergarten, and slowly this turns into, like, from little comic books, it slowly turned into big books of 300 pages. Then it turned into reading research papers. Then entire knowledge in this world is available out there for free. Only thing is, do you have the key or skills to exploit them? Like, there is everywhere, basically, let's say we can consider it, there are treasure boxes available all out there. Basically what you have to do is you should know how to open those treasure boxes. And if you know how to open that box, there is no barrier. And that is, learning is a continuous process. The day you say, I have learned everything, that means you are dead or you have become God. There is something we call first principle thinking.
Right.
Every big problem in this world can be broken down to the very fundamentals.
Basics.
Like, you keep on breaking down. Let's say simple. We are a very complex body, right? As a human, we are a very complex entity. But you keep on breaking it down, we are made of the same things, the atoms, which make, let's say, a non-living thing. So the fundamentals are same. And if you develop that approach of solving the problems at the very fundamentals, I think you can easily tackle any issue, no matter how big it is.
You have said everything what I really believe in. I do two podcasts. There's another podcast which I do, which is AR, VR focused. And my continuous effort has been to raise awareness on this basic insight that that every individual in this world of any class, any class, be it low class, high class, whatever, if he's got the desire and intent, if and only if he uses that desire and intent to push him to access like you mentioned, the treasure trove of knowledge which is available on the internet, anybody and anyone can create whatever he or she wants to do.
Right.
That the only thing that stops you is that block that you create, that, oh, this is too difficult, this is too way beyond my reach. If we believe that we are capable of going beyond, that is the time we will create change and true transformation.
Right.
Transformation which will really then change the world. So let's start with -0. You are building a startup which is, you are aiming for self-driving vehicles, and in your website it said that you are aiming for like level 5 vehicle. So let's just break it down. I mean, let's go from ground zero. What's the vision and what's the roadmap ahead?
First, we have to understand that if something works in US traffic, it will not work in Indian traffic. Currently, there are 3 major challenges in self-driving industry. Number 1, you need lots and lots of data. I think this is both a curse and a boon. Boon is that with increase of data, the accuracy increases of the AI model. But that is also not the approach how AI works, right? To a human, when you are, let's say, when you are a baby, did anyone show you 10,000 images of a bird to make you know that there is a bird in front of you? You have very basic knowledge. Okay, bird has 2 wings in most of the cases. It can fly in the most of the cases, and it might be very small. These are like few basic fundamentals, and using that little information, you can get a maximum amount of insights. And that is what needs to be changed. The approach, like too much data dependency, is not the right way. Because the thing is, let's say Tesla has collected billions miles of data. Waymo has collected 2.1 million miles of data. Cruise has also collected considerable miles of data. But thing is, data dependency is very major problem. Second, the approach to driving is quite different. Let's say in a foreign country, you can drive on a certain rule-based systems. But in India, no one follow rules. Anyone can come on the road anytime. The roads are not properly structured. So let's say a simple example. In foreign countries, they detect lanes, like lane markings, and plan their path accordingly. They detect lane markings on the road. But in India, you can't detect lane markings. There are no lane markings. In India, you can't detect roads because it's broken most of the way. So simple approach is that instead of trying to detect road, you try to detect a drivable area. To get the right solution, you have to ask the right question. There's certain companies who are strong believers of the end-to-end learning approach. And there are certain companies which you say LiDARs are very essential, since you can't make a safe driving environment without a LiDARs. And then there are companies like Tesla or -0 who believe that driving cannot be end-to-end because there are a lot of gray areas which you can't comprehend or understand. You have to divide the driving task into a number of smaller subtasks, let's say 20 or 30, and try to perfect each of those individually. And then obviously, as I would say, the entire industry is trying their own approaches. So it's a race. Let's see who wins. We had a different approach. Basically, it started as a research paper on AI that is less dependent on data. So self-driving car is something that could be achieved at most quickest pace with that kind of AI that I'd been working on. And obviously, it might be in future expanded to, let's say, unmanned military missions, unmanned space exploration missions. Let's say you're sending a rover on Mars, right? Or you're doing a surgical strike without any control. So there are a lot of applications, but yeah, self-driving car was the most feasible that could be implemented in the shortest amount of time. So we chose it and it was the need of the hour. So I think that's how -0 started.
There are some of the top minds, some of the top companies around the world are collectively trying to find out ways, and everybody's got their own approach. Somebody is working on lots of data, somebody is working on different architectural framework of deep learning, reinforcement learning, somebody is looking at lidar, somebody is looking at cameras, somebody is looking at training the vehicles and virtual models, and then implementing it onto the physical world, and there has been quite a lot of progress. The only thing exciting of the COVID was the pace at which the vaccine came out. The vaccine normally takes around 5 to 10 years to come out with the testing and stuff like that. The only reason it came out in under 6 months, and it's a world record, is because the world came together. It collaborated. And I believe that that's the need of the hour, and that's calling out that all these big companies needs to join hands and have an open source framework where the entire code and the hardware is available out there, so that people can collaborate on it, and individually these companies who are working, or startups from around the world, could add their bit to those framework or architecture to accelerate technology. Now, obviously, the way we function, we function in silos, and because we have the capitalistic structure that everybody is really hungry to, become a multi-billionaire, will never let that happen. But if we take that approach, the entire world will see technology accelerating, and the positives impact of that much sooner than the way it happened.
Yeah, I guess that's the very vital point. The thing is, do what you are best at. Do not try to put your hands into everything, and that is how this comes evolved. Let's say, as I would say, we have expertise over let's say basically on the software and the hardware of the self-driving part. So it doesn't mean that just to get very much capital, we have to manufacturing car on our own. Thing is, that is why even as a -0, we did, we are good at one thing, but for manufacturing the car, we'll partner with a certain OEM who already has those resources or plans. And that is how even most of the companies in the self-driving industry has worked. Cruise has partnered with GM, Argo AI has partnered with Ford and Volkswagen. Then Hyundai partnered with Aptiv. Because the thing is, but like this was one stage, and I believe we can go a little way beyond that also. A lot of new partnerships can happen. Let's say even if our goal is self-driving electric vehicle, right? That is our goal. But thing is, that is not something that we as -0 would be able to do alone. Why? Our forte is self-driving vehicles. We do that. For manufacturing that vehicle on mass scale, we need collaborative effort from OEM to help pass the legal regulations, because that is the biggest hindrance in autonomous vehicles. We need the support of journalists and broadcast media to drive that message out. We need the support of government, right? For electric cars, even OEMs need the support of certain startups who are solely working on battery technology, because I think that is the biggest challenge. Batteries are lithium-ion batteries are very costly.
Right.
So any innovation that is basically disruptive needs a collaborative efforts.
Would you kind of like to break down to my audience, what does it take, from the hardware side and the software side to build an autonomous vehicle? So maybe you can just give a lowdown first on the hardware, and then maybe the software side, like a brief overall structure, and then maybe you can get on to later on, like what is that -0 is building.
Okay, so I'll break the self-driving problem to like 5 major steps. Okay, you have a certain car, right? Now there like basically 5 steps. There is one what you call a system supervisor. That is like the supreme brain of the car. That is, let's say, coordinating all the. See, there are multiple things. There is sensors, there are cameras, there are all those things. So first task is we need someone to supervise. That is what in corporate environments happen. You need a leader who can calibrate and coordinate all the different activities. So there is one supervisor that is governing. Now, first part puts from the sensor. right? And for this part, there are different approaches. Some use LiDAR, some use only cameras, some use combinations. So this is okay. First task is getting input from the sensor, right? Second task comes perception. Perception means seeing what is around you. It can be learned basically from, see, the computer doesn't understand the way, okay, you are Eddie, I am Gagandeep. The computer doesn't understand that. So you have to make it believe, like make basically mathematical, show the computer mathematically a way that what does an image mean? Because let's say each image has, if you create a photograph, what is photograph? It is a like set of numbers. Like each pixel has a value, that is intensity of pixel. So computer understands numbers. So that first part is perception, seeing the world around you. And there are things from, let's say, object detection, 3D object detection, segmentation, all those things. Like there are different approaches in that. Next part comes, there are two things that go hand in hand. First is localization. Localization means where exactly you are. Basically, for perception, you have certain inputs from perception that, okay, the computer knows there are cars around him, there is this, right? Now you have to understand where are you exactly. Basically, from GPS sensor, you have to know, okay, I am at this road, I'm in the center of the road, or I'm the side of the road. That is, you should know where you are. And simultaneously, you should know what all others are. This next come mapping. What is mapping? You create a map of things around you. Okay, you have a camera that captures, okay, there are two cars, there are five, let's say, motorcycles, there is one. Now you have to map it, basically kind of plot those things on a map. Okay, there is one object which has this coordinates and it is moving at this speed. There is another object that has this much size, it is moving at that speed. And you are in the center. You have to basically create a map where all the other objects are and what speed or acceleration they are. These are the two things, localization and mapping. Next comes basically motion planning. Okay, you know what is around you and where these things are. Now you plan a motion. Okay, what path should you follow? And there are different types of motion planning. One is the top level, that is from A to B, you rely on, let's say, Google Maps, that, okay, you have to go from Delhi to Bangalore, right? That is one big mission. Then comes motion planning, the sub level. That means, okay, which road you should take. There are multiple roads to go to the same destination. You should take National Highway 1 or 2, or you should take the link road. That is next thing. And last comes what we call behavior planning. There are certain objects around you and how you avoid those objects and drive safe. So planning the path, this is next step. Next comes control design. What is there? Okay, the path says, the computer says, okay, you have to go to like left, right, and then you have to make this curve. Computer tells you have to go through this curve, basically, let's say a smooth line. Controller's job is to basically make those, like, to achieve that path, to travel on that path, what inputs need to be given to, let's say, motors that are turning the steering wheel or the acceleration values, and making sure that the driving is smooth. No one wants, like, suddenly it breaks and there are jerks and something. So making that smooth, there are smooth turns, like there should not be sharp turn, because eventually the rider, the passenger needs to feel comfortable. So it optimizes those values. There are also algorithms for that, how to optimize those values to make a smooth driver, like to turn, let's say, basically go 5 meters in the reality, what value has to be given to the steering wheel and the accelerator and the brake. And final thing is control actuation. Control actuation means the hardware that you have installed on the car, let's say motor or something, which basically turn the steering wheel for you or press the accelerator for you. This is the entire concept of the basically self-driving problem. These are the 5 steps.
Right. So would you like to talk about your solution? What is the framework that Minus Zero is building? Is it indigenous? Is it something that you have built on your own? Is it something that you've taken from open source platform? Please would you like to break it down?
It's a mixture of both, I would say. We have, I would say, for certain things, we have learned from the past mistakes of the companies like Tesla, Waymo, Cruise. Like they're often, because that is what, do not start doing everything yourself. There is a lot of things you can learn from the mistakes of others.
Exactly.
So our first step was learning what did they do wrong And then we figured out the solution. Okay, this was why the Tesla car crashed during that time. This was why Waymo's car had crashed during that time. Like first learning from what worked for them and what did not, and what has been open source. Because you do not have enough time to do everything from scratch. So you need to find out, okay, this is the thing that is open source, this is the thing that we can use. Obviously, there are, let's say, for even coding, frameworks like PyTorch or let's say TensorFlow, these are open source. So right, some things have to be taken, what works well. And now when you know, okay, X, Y works, but Z and ABC do not work. So for that, you try to figure out different, basically another approaches. So this is what, this is how we tackle the problem in the bigger level. Then obviously our main three USPs are, we are particularly making this system for Indian traffic particularly. And what is the biggest advantages? We do not need a million miles of data to train our model on. We need very small amount of data. Basically, this is more of, let's say, a makeshift solution of artificial general intelligence only. Not everybody, but let's say it can be artificial general intelligence only for autonomous vehicles. If I would like, because I can't reveal the exact approaches. As far as our approaches, we divide the entire driving task. Instead of taking the driving as a one task, we make it like into number of subtasks. Let's say 25 or 30 subtasks. And all those subtasks, like in normal cases, the entire driving task is data dependent. For us, particularly, let's say 5 or 6 of those subtasks are data dependent. We need to train them with data, and other things are calculated from the outputs of the first subtask. So basically, these are a couple of approaches, and self-driving problem is not just that is there is a one solution. Each part, each subtask has different approach to it. So they all combine to become what we call self-driving, or let's say what we are achieving level 5 autonomy. So in terms of basic USPs, we do not need that much amount of data. For like a Waymo has collected 2.1 million miles for just driving in a particular city in San Francisco and Arizona. But what we are saying that our tech basically for, let's say, I would say 100,000 miles of data, with that much data specifically collected, we will be able to navigate through entire India and through entire world basically. What Waymo has done for one city, how much data, we'll be able to do that basically for the entire world in basically, I would say, 82.3%. That is what our calculations, 82.3% less data, but for entire world.
So sounds interesting. So sounds interesting. Your speculation. Yes, please.
This is not a speculation. This is kind of calculated. We already have 2 patents pending. So like along this line, we'll have certain patents along the way. So it seems too good to be true. But that is what, if you have seen that driving rickshaw prototype, I believe.
Right, yes.
We basically retrofitted a rickshaw. And I think that was a world record, I would say. For the first time, a company was able to make a vehicle drive without any driver. Like there was no driver sitting on the driving seat. That too in Indian traffic. And it was developed in the span of 4 months.
I will stress that it was far away from a peak traffic scene, was on pretty much open road. Now, these in India, the traffic can get extremely drastic, from your potholes to people crossing on the street, not really caring about traffic signals not working, politicians blocking traffic signals, tree branches blocking traffic signals. Then there are taxis who don't have rear view mirrors. They use their hand to show their direction. The crazy weather situation. So I can go on and on of the problems of Indian road condition and the extreme weather condition, fog and rain. So yes, if we manage to create a system that can work on Indian roads, I'm sure it will be able to tackle the international road very well. But now I'll go back to what you said. I think you said something very interesting. You said that you have been learning from the big companies' mistakes. Now that is such a plus point. I think that is something which I want my audience to understand and startups to understand, because and we have the data of the mistakes which have been done by some of
Right.
the biggest companies. They have spent billions of dollars. The startups have the option to look at all those data and
Right.
create from there, add our own framework. So if coming back to your rickshaw that you build, and you said that you've done it in 4 months, superb, congratulations. How many miles it has done so far? What
Okay.
has the data that you managed to collect, and what are the
Right.
learnings from there?
Right. So the thing was basically our product that will be able to drive on Indian road, but like in typical, let's say Delhi Sadar Bazaar or typical Bombay traffic, that would be complete by mid 2023. So this was not our product. This was just, I would say, 7 or 8% of our entire technology. So this was not something to say that we have built the entire thing. This was just to give confidence that, okay, with 7 to 8% of our thing built in 4 months, we were able to handle, let's say, a little bit of Indian traffic. So you can just simple unitary method, you can imagine that when we close to 100%, that would be able to tackle. So this was not a product. It was more of a trust building exercise to convince people, to convince investors, and prove that this is not like, everyone would say, how can two undergrad students tackle a problem that the big researchers have not been able to tackle? So sometimes it's say, I do not believe in the fact that you keep on claiming things. I really, I do not like that sort of thing. So we were like, okay, we have limited resources. We are not claiming anything. We will show you what we can do. So that thing was basically, rickshaw was developed in a budget of 50K rupees, 50,000, that was put in by founders. And we were like, okay, see, we can show you our capabilities. We will not make any claim that, okay, we'll do this, we'll that. We'll show you, okay, this is what we can do in this much time and this much money. And now you can judge by our actions and not by our claims. And I think that is very important. Let your actions speak. So this was not a product. It was just a small validation to test our technology. And for that also, there was like lot of simulations had to be done previously to ensure that it will be safe in that kind of traffic. Obviously, I would say like it was not much compared to the traffic you find in Delhi or let's say in Bangalore, very high traffic. It was not exactly entirely an Indian traffic, if you would
Right,
say.
exactly. Yes.
But compared to the resources we had, the time we had, proof of concept in the mind, to implement that and doing all the testing and make it safe enough, it will take us 3 years. And that is the priority, to make it safe. So, yeah.
Right. So congratulations once again, because I think if that's a prototype, then the prototype is really, really cool. So you are saying that you will need maybe like a 3 years rough timeline to get into the frame, building an actual product is
Right.
what you're looking at, right? So what is the
Right.
go-to market strategy? Is it going to be a retrofit kit that you're looking at, that you're
No.
building, or are you looking at building a solution and then tying up with OEMs and saying that this is what we have?
Right. There is a difference between a project and a product. The project can be experimental, but the product has to be safe enough. So for that safety, there needs to be certain considerable differences in the dynamics and the structure of the physical vehicle. So that is what our target is. Like we'll be developing up to certain level by, let's say, end of this year or Feb or March of next year. And throughout the time, we'll be like, by that time, we'll be partnering with a major OEM, any, let's say Tata, Hyundai, or to basically build the vehicle from the scratch in collaboration. We expect the cost of building an autonomous car or even a good EV car, let's say like one like Tesla, that will maybe cost around 25 to 30 lakhs. That is already unaffordable for most of the public, for the general public. So to reduce that cost of ownership, we'll be catering to a shared mobility basically model. Okay, you have a robotaxi, driverless taxi that is available. Click a button on your phone, the driverless taxi will come to you. It will take you anywhere you want. Because we need to reduce the number of vehicles on the route. Because the thing is, electric vehicles can solve the pollution problem, But the traffic congestion, cannot be solved by electric vehicles, because that is dependent on how many vehicles are there in the world. And most of the, let's say, everybody's car is parked in his garage 95% of the time. They are driven only 5% of the time. So we can utilize that 95% of parking the car, we can put it out on the road, so that we can earn more. Basically the country as a general economy can earn more. The number of vehicles will be less, the pollution will be less, the traffic congestion will be less. So that is, but thing is, I would say our product is hoped to be ready by 2023, provided there are no legal hurdles, because in India, no regulations have been passed for self-driving cars. Safety regulation, liability regulation, and privacy regulation. Safety, whether the vehicle is safe or not. Liability, if the car has an accident, who will be responsible? Owner or the manufacturer or the rider. And third is privacy, what data you are collecting as a company, whether it violates the privacy of a certain consumer or not. So laws have to be defined for that.
Right. Yeah. So the second and the third parts, I mean, they are so very confusing at this point in time. I mean, what about the ethics? If and when we get into if we have a level 5 autonomous vehicle, and if the vehicle meets with an accident, who is blamed? The privacy again is such a huge concern. There is, when like I mentioned, I think we are getting into a world where everything physical is going to be digitized. The digital twin is going to have huge economical value. That will create HD maps for your autonomous vehicles, for it to move smoothly in the physical world. I know that we don't have anything clear on either the regulation or the ethics or the privacy. There is nothing which is concrete, but would you like to share some light on that?
Actually, we at -0 have this, like our at -0 technology is just 30%. Our primary focus areas are these two. And for privacy, as I said, we do not need to collect the video data. So what our vehicles collect is basically, they will collect a driving score. Driving score is like, we are not collecting any video data. We will not be uploading anything to the cloud. Our vehicles can run independently. Since that AI is less dependent on data, it can work on cheaper hardware. It needs not to be like, we do not need more data to train our model. So what we are gathering is driving score, okay? Like there is parameter, how many potential collisions avoided, right? What was the average speed? Was the ride smooth or not? So like from all these parameters, the vehicle will give a marks to the ride out of 100. Like out of 100, this was 60% good. And we just need that kind of score. So that is what we are, that's why that is one of our USPs. The AI less dependent of data in turns, as I said, reduces dependency on data. So we do not need that kind of data. So it doesn't matter wherever the person is traveling. We are not taking any location data or any video data. We'll be collecting data that will be stored on the vehicle. We cannot access this. Others cannot access it. And let's say the regulatory authorities, when there is an accident, they access it. Now the thing is that data is, you have 360 view of the vehicle. 8 cameras are there, 8 cameras, 6 lidars, 12 ultrasonic. So they know, right? Now, if there is a technological glitch, let's say a certain motor fails, or let's say the AI doesn't work properly, we are ready to accept that liability as a company, because we are, as a researcher in that, we are making sure that those kind of things never happen. Right, that is our priority. But there is often data, let's say someone intentionally, a drunken driver slams a car from behind. In that case, even a human driver can't do anything. You are driving a car. If someone other slams it very speedily from behind, it's not your mistake. So we have that data which makes the investigation easier. That okay, if a car crashes, you can get the regulatory authorities and get the data out. And they can see, okay, if the other person intentionally slams the car behind, then it's a responsibility of the other person. But if there is anything that is due to the technology that we have developed, or some motor sensor fails or something, we are ready to accept that liability. Right. And I think these are, ethics should be solved by the very fundamentals. If it's your mistake, you have to be liable for it. If it's not, you can't be forced to be liable for that.
As a small startup, data might not be that important, but all the big companies, all that they're doing is collecting data, because data is the new oil. Most of the advances that we are seeing in artificial intelligence, machine learning, or whatever, is due to the humongous data that is being gathered. And through the data of the learning, we have created advancements in or machine learning or artificial intelligence framework. And besides that, these big companies have been selling data and manipulating data to sell products. Because when anything goes free, that means we are the product. There is no shortcut to anything, not in life or not in building things, because it is going to take time. Yes, we will reach level 5 autonomy. How long? I don't know, and I don't want to speculate, but yes, there are some of the biggest minds, biggest companies are working on building a level 5 autonomous vehicle. And I'm so glad to be talking to a 20-year-old who is aiming to solve that problem. And I wish you the very best. And I hope that we have an Indian startup solve that problem. Who are the leaders you think will be the first to reach to level 5 autonomous vehicles? And who are your inspiration?
Say people can steal your idea, but what thing they cannot steal is your execution. Your execution is what defines you. And execution means 3 things: planning rationally, having the guts to start first, because half of the people do not even start. So that for the execution, we had we were inspired from, I would say, Elon Musk, but there are many other people who basically inspires different aspects of our life. There are certain things where I would say Elon Musk might not be the best person for certain aspects of life, right? He is not what you call the best person in the world, but for certain things, he is very great. And for other things, there are other people who are better, right? So that is what, learning from everybody around you. I think asking the right questions and not having an what you call ego that why should I learn from him? Even let's say a child that is smaller than me, sometimes it's often happened that a 5th grader eventually ends up teaching me a certain concept that I would not have figured it out on my own. So this thing, I think, to do anything in the world, firstly, you have to learn how to ask the right questions, because answers are already there. The universe has the answers. Like, let's say if we have, I would say that we are researching on God particle, the Big Bang theory and all these things, particle physics. The universe out there, the stars, they already have those answers. And what the scientists have to do, they have to ask the right question first. That is one thing. And second thing is, you need to have the humility to learn from anyone that is available out there. Even during this interview, I got certain insights from you that I would eventually be using to make certain, let's say, decisions or certain thing, because everybody is adding value to you one way or other. It's up to you whether you choose to accept those things or not. That humility is very important.
It was a complete pleasure talking to you, and you said right thing. I think you need to have an open mind. You need to have curiosity, because I think it always starts with that. If you're curious, you will always find answers, because the answers are there, and there's nothing which is impossible. And yes, I'm so inspired by you and your passion. Young man is building the future of mobility of India. And if he gets it right, and if he is at it, like, there's this saying of how a spider or an ant, when he keeps on crawling and he does not give up. That is would be my only advice to you. You are at you are asking the right question. You have to keep at it. And if you are at it, you could be one of those guys who would be building the future of mobility in India. And yes, you're a lifelong learner and you're open to learning. That's the only way where you'll be able to build really cool thing. So, Gagandeep, wish you the very best for your venture. Wish the minus zero becomes the driver of the future of mobility in India. So, in that note, to my listeners, if you like what you see in here, please press the subscribe button. And until next time, see you guys. Bye bye. Thank you.